A booster ignites, and an XQ-58 Valkyrie launches off a mobile rail like it's being fired. It doesn't need a runway, just a launcher and a few minutes of setup before it disappears into the sky. It was built to handle missions that kill pilots, such as suppressing enemy air defenses and conducting first strikes into contested zones. Unmanned means expendable. Now it's gained a new capability, to land and relaunch from any flat surface. The Marines just made their air power impossible to eliminate with a single strike. On January 8, 2026, the Marine Corps moved to bring the Valkyrie unmanned combat aircraft closer to a real program by funding a build and test effort aimed at a deployable aircraft. Its aim is to operate an uncrewed jet that can work in forward areas where fixed bases are vulnerable and long runways may not be available. The XQ-58 first flew in 2019. Now, after years of testing and incremental development, there are public reports of a new contract step under a Marine Corps program called MUX TAC Air, linked to the Marines' Collaborative Combat Aircraft track. Now, the work on this aircraft occupies its own official lane with clear jobs. Northrop Grumman serves as the prime integrator for the effort, while Kratos provides the XQ-58 Valkyrie aircraft system and manufacturing base. Northrop's role points to where this is headed, since the aircraft has to carry mission gear, plug into Marine and joint networks, and run software that can change with tactics. The evolution of the airframe aims to move the aircraft from demos to a mission-ready configuration. Reports about this issue describe Northrop as supplying a mission kit, plus autonomy software, which will in turn make Valkyrie into a platform the Marines can assign tasks to without rebuilding the aircraft every time the mission shifts. The announced contract structure is designed to support rapid iterations. Its award describes it as an other transaction authority deal, valued at $231.5 million over an initial 24-month period. OTAs are used when the Pentagon wants faster delivery and quicker updates than standard procurement usually allows. The Marine Corps anticipates operating in environments where fixed airfields are exposed to attack and may not be repaired quickly. In that context, the announcement fits the service's move toward aircraft that can be placed forward and shifted rapidly between sites. A program with a defined mission and a clear development plan, especially one that can be supported with limited personnel and equipment, is more useful than any demonstration effort. This contract is intended to move Valkyrie in that direction and make it something units can incorporate into planning. The XQ-58 Valkyrie is an unmanned jet built for a problem the United States cannot outrun. The best aircraft in the force are expensive and slow to replace, and they still depend on bases and support infrastructure, which can be hit. Modern fighters are highly capable once they are in the air, but they take years to produce and require long training pipelines for pilots. They also depend on a functioning support system consisting of many parts that need to be almost perfect. Usable runways, steady fuel supply, spare parts, and predictable sortie generation. In the fights the Pentagon plans for now, those support points are not safe. Runways get cratered. Fuel farms get targeted. Satellites and drones can track airfields. Jamming and cyber attacks aim at the data links that hold an air package together. The threat is not only that aircraft get shot down, but that they can't get off the ground at all. Valkyrie is meant to give commanders another option. Designed as a jet that can be produced in larger numbers and flown without a pilot, it's built to operate where the risk is too high for crewed aircraft. The Pentagon often describes systems like this as attritable, which are aircraft that can be lost and replaced without collapsing the plan. Better yet, it can fly closer to air defenses, forcing radars to react and take exposure that would otherwise be pushed onto a pilot. This also explains why Valkyrie keeps showing up in the collaborative combat aircraft discussion. A platform like this can fly alongside manned aircraft and extend what the latter can do. It can push sensors forward to widen the picture or pull fire away from manned jets. And it also has room for mission gear. Its inner capacity also allows it to carry mission equipment that supports other aircraft, and in some configurations, it can carry weapons. In a high-end conflict, a small force of aircraft is easier to degrade. Losing even a few high-value jets on the ground, or even having sortie rates reduced by attacks on bases or fuel lines, can quickly cut available air power. One purpose of Valkyrie is to offset that risk by adding lower-cost aircraft that can be procured in larger quantities and used in roles where losses are anticipated and planned for. Therefore, if this aircraft is meant to keep flying when bases are under attack, then the most important issue is not only what it can carry or how far it can go. The most important issue is how it launches and how it recovers when runways are damaged. That's what Kratos is offering, and it could reshape how the Marines fight with this jet. The baseline XQ-58 Valkyrie was designed to operate without a runway. It launches with rocket assistance from a static rail launcher, then returns at the end of the mission under a parachute. By removing the landing gear entirely, the design frees internal space and avoids dependence on a conventional airfield. However, it opens the door to a slower reset process than normal flight operations. Parachute recovery is workable, but it slows the reset cycle and adds failure points. This is not how high sortie rates are normally generated. To avoid this, the Marine variant is being built to change the end of the mission. The new configuration is CTOL, a conventional takeoff and landing, meaning it carries landing gear and can operate like a standard aircraft on a runway. Kratos has confirmed that this landing gear Valkyrie will still be able to launch with rocket-assisted takeoffs from static launchers, and then recover by landing conventionally on a runway. Plus, it uses the same launcher architecture already available. This pairing is intended to support a different operating model. With it, launch systems can be positioned away from main airbases, allowing sorties to originate from dispersed locations, while an adversary concentrates its search and targeting effort on fixed infrastructure. Then, instead of drifting down under the canopy and waiting for a recovery team to secure and move the aircraft, the Valkyrie can land on a usable runway at a secondary location and enter a faster reset loop before launching again. In that sense, the unit can initiate operations from dispersed launch locations, then transition to conventional runway operations for follow-on sorties when suitable airstrips are available. It can also relocate again as the situation changes. That approach increases the complexity of an adversary's targeting effort by requiring them to track and threaten both launch sites and recovery or support locations, rather than focusing only on fixed airfields. Another benefit of the CTOL Valkyrie is that the same basic airframe can support two operating modes. On the one hand, it can use a conventional runway when one is available, but if needed, it can be launched with a booster when runway access is limited or undesirable. One of the trade-offs is that the retractable landing gear occupies internal space that could otherwise be used for fuel or internal payload, a trade-off Kratos has publicly acknowledged, even if external carriage remains an option. Furthermore, in many cases, a booster launch limits takeoff weight, which reduces payload and range. It also adds a consumable requirement. Rocket boosters have to be stored, transported, and resupplied in numbers to sustain operations. If this concept works, it changes how American airpower survives the opening hours. The familiar model concentrates aircraft at a small number of major bases and measures readiness by how quickly those bases can generate sorties. The shift now underway, visible in the Marines' MUX TAC air push and the Valkyrie variants being developed for it, is that the runway is no longer the single gatekeeper for getting aircraft into the fight, even if it still matters for recovery and sustained tempo. In this model, the runway becomes one option among others, not the foundation on which the whole system rests. Marine Corps budget documents frame the direction in clear terms. Quote, "The uncrewed weapon systems under development will enhance Marine Corps aviation's lethality and ability to support the stand-in force, or SIF, by delivering air-to-ground, reconnaissance, and electronic warfare, or EW, capabilities." Taken together, this effort is not only about focusing on what a single aircraft can do. Rather, it reflects a military approach that will now treat launch and recovery as variable elements of the overall system. Under that logic, an adversary can still strike airfields, but the intent is to reduce the certainty of those strikes once promised. Cratering a runway can disrupt follow-on operations, but it may not automatically stop an opening wave if aircraft can still be launched from static rails away from the main base. It also increases the odds that an enemy wastes weapons in the wrong location while the real launch point keeps operating. This doesn't lock the Marines into runway-only operations. It's more like a practical starting point that can be expanded over time. Valkyrie's modular design makes that easier, since now the same jet can be set up in different ways, without turning into a whole new program each time. In operational terms, the decisive factor may be scale rather than marginal performance. The advantage will favor the side that can generate aircraft numbers, keep them supplied, and sustain sortie output under pressure. That places emphasis on production timelines, support capacity, and the ability to introduce updates as threats change. Northrop's work centers on mission system integration and update pathways, while Kratos continues producing the air vehicles and sustaining output. Marine planning also assumes that movement and relocation will be able to change outcomes. Forces that can keep launching after initial strikes are more likely to maintain tempo. Kratos has stated that it plans a first flight of the CTOL variant in early 2026, which will be an early test of how quickly the concept is transitioning into hardware.